So the talk that I'm going to do is about the information that you can get from your build to change the architecture or the structure of your application. Let's do a quick show of hands. So who has a continuous integration or continuous deployment server? Yeah, roughly everybody. That's good. Now, what do you use I'm going to refer to these things as build systems in general. So what do you use your build system for? I guess to run tests and see if anything is broken, yeah? To deploy to production or test or anything like that? To run static code analysis, maybe? Okay, a few. Do you use it for anything else? Okay, let's look a bit deeper into what we use our build instance for. Usually what would happen is we have the build system running. If anything is broken and we have a red light, then we go to our code and do changes. How about if everything is green? Do we do any changes to our code when things are working? Does anybody? No? That's right. So this is what I found interesting. The build systems have a lot of information, but we only use part of it. We only use the broken part. How about the working part? Now, let me go through a real system. This is a system I worked with. It's probably going to be similar to something you've been working on. So each bubble, as you can imagine, represents a build configuration. That build configuration creates its own artifact. The bubbles on the right-hand side, they are WAR files that produce different web services. And then there on the bottom left, we have a couple of artifacts that are kind of used everywhere. That's why they have these little arrows. And one of them is a parent POM. And everything else produces a jar file. The arrows indicate the triggering dependency, or the code dependency would go in the opposite direction. So here's what I did. I took this code, or I took this system, and I decided to analyze it for a period of 2 months. So I took 2 months' worth of commits, and I looked into where are we committing the most. And it turned out that roughly a quarter of the time, all the commits went to that particular bubble. Which in a way makes sense, because when you're building something or when you are working, you tend to work around themes. You don't work in a functionality and then tomorrow in a completely different thing, right? Everything goes around a particular theme or topic. And if your system makes sense, then your themes will be sort of concentrated on builds, and that's why it makes sense that builds concentrate on that particular bubble. Now, if that is built or rebuilt 28% of the time, that means its dependencies are roughly rebuild 28% of the times as well, right? Obviously, you won't be exactly the same number because sometimes the first one will fail, which means the other ones don't trigger, but we can make that number. Then I looked at the next most built system or component, and it turned out to be that one, about a fifth of the times. And then again, if that one is rebuilt 20% of the time, then the next one in the chain also gets rebuilt, which means that one is rebuilt about half the time that we do any commits in this system. What I started to see here is kind of a pattern. So we have builds that are built a lot, that we can call hot builds, and then probably we have builds that are not built very much, and we can call the cold builds. So I wanted to show this graphically, and what I did is, this thing that I did on the percentages, I actually applied to the whole of it. I took the building data of those 2 months, and I checked how many times each build configuration was rebuilt, and I applied a color, a temperature, according to the frequency of that particular build configuration being rebuilt. And it looked like this, right? So we have some cold builds, like for instance, the parent POM and the login. They're not built very often, which makes sense because they are very basic thing, and you don't want to rebuild your very basic things all the time. The WAR files are rather hot builds, which also makes sense because whenever you change anything, eventually it's going to rebuild one of the WAR files. So those are things that are built very often. But we start seeing things that are interesting. For instance, if you look at this one here, that one is a relatively warm build. It's not the hottest, but it's relatively warm. It only has one dependency, and its dependency is rather cold. That means that if you're rebuilding this one, it's not because of its dependencies, it's because you're making changes to that build configuration, right? That component is receiving a significant number of commits. If you follow the arrows there, if you follow the dependencies, the builds coming next, they have roughly the same color, which means they're being rebuilt roughly the same number of times, which means they are not being rebuilt because you're changing them. They're just being rebuilt because their dependency was changed. So we can see here, just by seeing the colors and the dependencies, that maybe this build configuration here, or that component, is doing too much. It has too much code or too many responsibilities. And that's why you're changing it very often, and it has many dependencies that depend on it and that need to be rebuilt because you're changing that one. Right? And then I thought, okay, this is interesting. How can I use the build information a bit more? So I thought of adding another dimension to this picture, which is the build length. How long do they take? And the way I could represent that is by sizing these bubbles according to the build length. And then it looks like this. Again, it sort of makes sense. The WAR files, they're really long builds because we have to create a WAR file, and then we need to deploy it into Tomcat, and then we need to run a series of integration tests, which are very slow, which is why these bubbles are so big. The POM file bubble, a really small one, because you don't have to build or test anything. You just check the validity of the XML and then straight to the Artifactory. And then this one here, it seems to be a bit bigger than the ones around, which is kind of reinforcing this idea of this component is doing too much. You have too much responsibility here. You need to split that down. And here's what I found interesting about that conclusion, which is we're talking about splitting down, about breaking down a component, and we don't even know what it does. We don't know what this system is about. We haven't seen the code, but we already have a clue that this is too big and we should break it down. Typically, when you analyze a component and you decide whether you need to break it down or merge it, you usually look at the code and analyze it and make a qualitative assessment of it. You think, okay, there's responsibility A, functionality B, etc. They should be together or should not be together. Here, what we're talking about is more of a quantitative approach. We're looking at numbers, pure numbers, and the numbers are telling us what we should be looking at and what we should be maybe merging or splitting. In the same way that we said that maybe this one is too big and we should split it, maybe these three components here, they're very cold and they don't seem to be very big, so maybe we should merge them and just create like a utilities package that everything else is using. I like to call this build-driven architecture. And the reason I'm calling it build-driven architecture is because we're making decisions about how you need to structure your application according to the information that you're getting from your build system. And it's not because you have broken builds. It's just the positive information. It's even when everything is working, you can get information from your system that tells you how you need to structure this. I thought of calling it data-driven architecture, but I realized this is not something new. We already use data to drive our architectural decisions. For instance, we use performance data. We run the application, we see where the pain points are, and based on that data, then we make change to the architecture. But we never used the build to decide the architecture before. And I think this is going to become more and more important as we go further. The industry seems to be going towards quick iterations. That means we need to rebuild things very fast, but we need to do them without breaking anything, because otherwise we will lose the trust of the users. That means you need very tight feedback loops. Whenever you do a change, you need to figure out whether things are working or not very quickly. In order to do that, you need a build system that builds quickly. If your build takes an hour to run, you're not going to get quick feedback. So then again, your build system, the information that you get from there is going to tell you how you have to structure your application so it builds quickly, so you can keep on doing iterations very quickly. So who likes this kind of thing? Who likes to have this kind of graph in their applications who like to have a Jenkins plugin or something that shows this? Yeah, I like it too. I haven't seen anything out there that does this. Maybe there is something, but I haven't seen it. So then what I'd like to do next is build it. So I'm trying to think of attending or creating a few hackathons or hack days or maybe a project in GitHub where we start getting this information out of our builds and creating a nice interface. I have started it. It's not very difficult. Most of the build systems have a very nice RESTful API that can give you this data. Jenkins has it. TeamCity has it. I don't know what you guys use, but it probably has an API as well. So it's just a matter of gathering that information and then creating a nice JavaScript or anything that shows this data live. And then there are many parameters that you can use. You can decide how long data you want to use whenever you create your graph. You could use very short data, maybe the last 2 weeks, and then you react very quickly to changes. Or you can get very long data, 2 months, 6 months, which means you're going to have a broader knowledge. You're not going to be swaying so much by little changes, but you're going to have a very stable thing over time. So that's pretty much what I wanted to talk about. I don't know if you have any questions about it or any thoughts or anything like that. Thank you.